Hi, my name is Cooper. I'm a math teacher and a data scientist, and I love to talk about math and statistics. Scatter plots are great. Who doesn't love a good scatter plot? Seriously, name something better than a scatter plot. I'll wait. Okay, so maybe scatter plots aren't that great, but they are still a lot of fun. If you are hands-on like me, then they're a joy to plot by hand. But you can also use all kinds of software to draw scatter plots as well. We are about to dig into what exactly a scatter plot is. Let's start with just a plot. What is it? Simply put, a plot is just a way to represent data in a graphical, visual way to make it easy to see patterns, trends, and other features that might not be obvious in a simple table. There are all kinds of plots, but scatter plots are unique in that they often allow you to plot all of your data and represent it in a way that immediately offers insights that otherwise might be hidden in a table of numbers. The simplest scatter plots are easy to recognize, usually an x, y coordinate plane with dots all over it. More complex scatter plots might have different colors or sizes to the dots, or maybe even different shapes. But in the end, all scatter plots have the data plotted as coordinate pairs, an x and y value for each point, and located on the graph based on their position relative to the x and y axes. The most common type of scatter plot involves plotting two-dimensional data points called ordered pairs onto the coordinate plane. The independent variable is almost always plotted along the x-axis and the dependent variable along the y-axis. Each ordered pair, x, y, can be plotted by moving along the horizontal axis, x units, and then moving up in the vertical direction, y units. Sometimes the independent variable along the x-axis is called the explanatory variable, while the dependent variable along the y-axis is called the response variable. It sort of makes sense, since the x variable often explains the response we see in the y variable. You can use either name, but just know that the explanatory and independent variables are the same, while the dependent and response variables are also the same. Different names for the same things. But scatter plots aren't just for looking pretty. The true value of a scatter plot comes from its ability to demonstrate a trend or a correlation. When we're examining data, we're usually looking for some kind of relationship. If both the x and y variables tend to get larger together, we say that there is a positive correlation between them. If, on the other hand, as the x value increases, the y values seem to decrease, we call this a negative correlation. Trends are useful because we can use this knowledge to make predictions if we know the predictive value of a measurement. For example, if the square footage of a house tends to increase with its sale value in the real estate market, this positive trend can help us predict the value of a house we might be interested in buying. Trends can be linear, if the trend seems to follow the path of a line. Or trends can be nonlinear, which can happen if a pattern is clear, but it seems to have some kind of curve to it. It could be exponential, quadratic, or something else entirely. Sometimes we take a look at the scatter plot and we don't see any apparent trend at all. It just appears as a big cloudy blob of points with no clear relationship, positive or negative. And that's okay. We just say that there's no correlation in this case. But don't be discouraged. When we're looking for trends and relationships within datasets, figuring out where trends don't exist is still a step in the right direction. Suppose that in our math class, we asked each student how many hours they studied for a particular exam and what they ended up scoring on that exam. Here is a table of values showing the data we collected. In general, did studying more for the test lead to students scoring better on the exam? By studying the table carefully, we might be able to get an idea, but it's not immediately obvious. Let's try plotting the data in a scatter plot. Since we believe that the number of hours studied could possibly be the value impacting the scores, number of study hours will be the independent variable and plotted along the x-axis. This leaves the exam scores to be plotted along the y-axis. Each data point represents a single student, their hours studied, and their exam score. Let's plot the first student's data. They studied for 2.5 hours and got an 84% on the exam. Not bad. We'll go to 2.5 on the x-axis and then up to 84 on the y-axis. We draw a little point here, and that's it. Now we can do that for the rest of our points. Notice that since the lowest score on the exam was a 62%, we don't have to draw the y-axis starting at 0. By cutting off this lower chunk, we can use more of the space we have to plot points. You're not always going to chop off parts of the axes, but it's usually okay to do with scatter plots. And look at that! We have a beautiful scatter plot with a positive trend, showing that in general, the students that studied more did better on the exams. Except for this one little dot here, every class has that one student who never studies and still gets an A. Scatter plots are some of the most useful and common plots we see and open up doors to all sorts of interesting insights that we can pull from data. We can add dimensionality to our scatter plots with color, dot sizes, and even shapes to create data-rich visualizations. For example, you could compare the average life expectancy and median income for different countries around the world. We'll put income on the x-axis, life expectancy on the y-axis. When we add a dimension, that just means we're adding another variable, another set of data. But how to plot that on a flat piece of paper? Well, we could add population data to the plot by adjusting the size of each point. We can also specify the continent by adjusting the color of each point. Now we have a really rich and beautiful scatter plot to show off. Now, just think of all the possibilities. What are some other interesting relationships you'd like to see plotted?